Alright, welcome. This video will be short, super sweet. Okay, so here, going back to this worksheet that you've been doing, this lesson 26 on solving rational equations. If we flip it over to the next page, let's just solve these two questions, and I feel like once you solve this one here, then you should be good to solve the rest of the problems in the worksheet. Okay, so let's look at the first question here. It's 3 over x is equal to 8 over x minus 2. And here, the first thing you should look for is, let's go back to this idea. What is the domain of each rational expression here, right? Here, when we talk about domain, if we just look at this, x cannot be what, right? X cannot be 0, right? Because if x is 0, this whole thing is undefined. And x cannot be what? X can't be 2. Because 2 minus 2 is 0, then this whole thing becomes 0. So that's very important before you start these whole problems, is that you have to look at it. X can't be 0 and x can't be 2. Because if these two are the case, then we have a problem. But okay, now let's just solve for x. Now here, I showed the same problem twice. There are two ways of solving. Well, there are multiple ways, but here are the two good ways. The first way, what you can do is, remember that game plan of getting the denominators to be the same? Here, you can multiply this by an x minus 2, and this by an x minus 2, right? And then you can multiply this by an x, and then this by an x, right? And the game plan is, if you have same denominators, then the numerators must be equal to each other. So here, you have x times x minus 2. You don't need to multiply it. It won't matter. Is equal to x times x minus 2. Now notice the denominators are the same. So then the numerators must be equal. So this is 3 times x minus 2, right? And this is 8 times x, right? So now we could just say that 3 times x minus 2 is equal to 8x. And that implies that 3x minus 6 is equal to 8x. So then here, if we do minus 3x, right? Then you have minus 6 is equal to 5x, and x is equal to, divided by 5 is negative 6 over 5. Okay? And that is our final solution. Let me just... My bad. Let me just double check and make sure everything is okay. Yes. Okay, that's the correct answer. I didn't want to make a mistake. So even though the answer is a little weird, that is a solution. Okay, so this was one way of solving it. Another way is, remember, if there are two proportions or two fractions that are equal to each other, you can cross multiply. So then you could just say 8x is equal to 3 times x minus 2. And then here, notice that this is the same as that, and we just get the same thing, that 8x is equal to 3x minus 6, and then this is minus 3x, and this is 5x is equal to minus 6, and then x is equal to negative 6 over 5. So this is our solution. Now, we have to ask ourselves, is this solution okay for the original problem, right? And can x equal negative 6 over 5? It can, because we stated that x can't be 0 and x can't be 2. So this solution is valid. This solution is valid. And this idea will be important for the next question, okay? So this was kind of a warm-up to that. Now, let's get to this guy. If we can solve these, then this is the big deal. Okay, here. Now, what do we want to do? We want to somehow combine these two fractions into one fraction and then have some sort of ratio. So what do we notice? What is game plan? Game plan. Get denominators to be the same for all three. We want all three of these denominators to be the same, because we could do that little trick that we did before. If the denominators are the same, then the numerators are the same. So here, one thing you have to notice, that this a squared minus 4, right? that is equal to, what is this equal to? That is equal to a plus 2, a minus 2, right? This is equal to this once we factor it. And notice that this is the same thing as these two guys. So if we look at this, this is 1 over a plus 2, and this is plus 1 over a minus 2, right? This is the LCM. This is the LCM of this term, these two terms, this term, and this term. So how can we manipulate? All right, that's going to be a very powerful word. How can we manipulate this fraction to have this denominator, and how can we multiply this fraction to have this denominator? So this has an a plus 2. What is it missing? It's missing that a minus 2. So let's multiply a minus 2 to this, and then remember a minus 2 to that. And then this is missing what? It's missing that a plus 2. So we're going to do an a plus 2 here and an a plus 2 here. Okay. And then what do we get? We get a minus 2, right? Times 1. So that's just a minus 2 over a minus 2, a plus 2. And remember, you don't need to really do anything with this denominator, right? And this is what? Plus a plus 2 over a plus 2 times a minus 2. And even though I just wrote them switched in a way, they're still the same denominator. And that's equal to what? 4 over a plus 2 times a minus 2. Okay? And what do we get? We get, notice that all the denominators are the same. So what can we do with this side of the equation, right? We have denominators the same. We can add the top. We can add these two. So this is a plus a is 2a, right? This a plus a is 2a, and minus 2 plus 2, that's just 0. That cancels. So this is a minus 2, a plus 2. That the denominator stays the same. Is equal to what? 4 over a plus 2, a minus 2. And now we play that game that because the denominators are the same here, that means that 2a is equal to 4. So divide by 2, a is equal to 2. Now, if you think we're done, this is where we fall into some little trap. Okay, this is where we fall into some little trap. Because here, let's look back. What was this question here that I kind of skipped until now? It says, what is the domain of each rational expression? You see here, a cannot be what? A cannot be negative 2, right? Because if a is negative 2, then we get 0, and that's no bueno. Here, a cannot be what? A can't be 2, because if a is 2, 2 minus 2 is 0, and that can't happen. Here, if you have a squared minus 4, and that's equal to 0, right? Then a squared is equal to 4, a is equal to plus or minus 2, so a can't be plus or minus 2. And now here we got a solution that a is equal to 2. So what is the solution? So what does that mean? What is the solution to this question? What is the solution? There is none. There is none. There is none. Here, this is an important idea that we need to talk about, is this idea of an extraneous solution. Okay? So an invalid solution may arise when we manipulate, right? We manipulate a rational expression. When we are doing this a plus 2 over a plus 2, a minus 2, when we're changing things around, we are manipulating the game. And when you manipulate the game, sometimes an extraneous solution may occur, such as over here. And now here, just for your definition, please have this in your notes because things like this may happen. All right, this is a very, very important idea, that an extraneous solution is a value, right? This is our extraneous solution. It's a value that satisfies the transformed, right? We transformed this equation. You see, this a satisfies this, right? This 2a equals 4 when we transformed everything. But it does not satisfy the original equation. So that's why this solution is extraneous. And you have to be careful for this because this may happen when we do these questions. Okay? Now, you could do the other questions using that idea of manipulating around. But now you have to find out if there are extraneous solutions. So if you solve something like this every time, you have to what? You have to check. You have to check to see what the domain is for all the rational expressions, and that you're not messing anything up. Okie dokie. Short and sweet.